Tengku, do you know about chromatography?
Oh, yes, I know about it.
Can you explain it for me?
Sure. Chromatography is a technique used to separate the components of a mixture based on the differences in the rates at which the mixture are carried out through a stationary phase by the flow of mobile phase. All types of chromatography contain a stationary phase that can be solid or liquid. To absorb or absorb the mixture being separated, and a mobile phase that can be liquid or gas, which passes over the stationary phase that carry the component. For the type of chromatography on the basis impression of the analyte with stationary phase, there is two types, which is absorption and partition. Type of chromatography based on technique will have liner and column.
One of the applications of chromatography is paper chromatography. Paper chromatography is an analytical technique used to separate and identify mixture of substances. It's a type partition chromatography where the separation of components is based on their different rates of movement through a stationary phase, which is the paper, while being carried by a mobile phase, which is the solvent. In the paper chromatography experiment, we use some materials and equipment. The first equipment is chromatography paper, which is chromatography paper acts as the stationary phase. Typically, this is a special type of filter paper. The second equipment is solvent, which is mobile phase. A solvent is a liquid that dissolves the components of the mixture. The choice of solvent depends on the nature of the substances being separated. The third one is sample, which is the mixture to be separated. And the fourth one is chromatography chamber, a container to hold the solvent and the paper. Paper chromatography is considered partition chromatography because the separation of the components in the mixture is based on their different partition coefficients between the stationary phase and the mobile phase. In paper chromatography, the stationary phase is the water or aqueous layer that is naturally absorbed onto the cellulose fiber on the paper. The mobile phase is the solvent or a mixture of solvent that moves through the paper by capillary action. This solvent can be polar or non-polar, depending on the nature of the substances being separated.
Do you guys know how paper chromatography works? No? It's okay. I will explain to you guys. Let's go! First thing first, the purpose of paper chromatography is to separate a homogeneous picture into its individual components. Oh, now I will explain to you guys what are the important things to understand in paper chromatography. In paper chromatography, they have two parts, which is stationary phase and mobile phase. First one is the stationary phase for paper chromatography is a liquid because the water trapped in the paper which made up of cellulose fiber. Filter paper are used because the paper are made of cellulose fiber that contain trapped water molecules. The trapped water acts as a stationary phase and the filter paper itself is the support. For the mobile phase, it is an organic solvent such as a mixture of ethanol and water. Now, I will explain to you guys how paper chromatography works. Paper is made of cellulose, which makes it is a polar substance. As we know, paper chromatography is a partition which the separation is based on solubility. The polar components will be more soluble in the polar stationary phase, which is water trapped in the paper. In this case, the polar components will be carried out late because it is attracted to the polar stationary phase. Meanwhile, the less polar and non-polar components will solute in the non-polar mobile phase, which is the solvent. In this case, the non-polar component will be carried out further up on the paper and will be separated from the other components. So, we can conclude that the more polar the component, the more rotation time it takes to going up further from the polar stationary phase.
So, for paper chromatography, as the solvent moves up, the cellulose fiber in the paper that acts as the stationary paper will dissolve the components and move them up.
So, the more soluble the component is in the mobile phase, the less it will be absorbed by the stationary phase, which makes them move faster and further. If the components are less soluble in the mobile phase, the more it will be absorbed by the stationary phase, and it will make them move slower.
Do you guys know, other than paper chromatography, there are also other applications of chromatography. The first one is biochemical analysis, which is separation of amino acids, proteins, and nucleic acids. So the second one is chemical analysis, which is identification of compounds in pharmaceuticals, food products, and environmental samples. And the last one is educational purpose, which is demonstrating basic principle of chromatography in laboratories.
Did you get it now yet?
Oh, yes, now I get it. But Tengku, do you know how to do paper chromatography experiment?
I'm not sure about that. Let's ask Aimie. Aimie, do you know how to do paper chromatography experiment?
I know that, but let's watch this video.
The first step is to prepare a filter paper and draw a spot line. Next, estimate the distance between the points of the substance to be spotted. And make sure to not spot the substance too close to the edge of the paper. Next, spot the standard substance and sample into the designated spot. Now, roll the paper into a cylinder and do not let the edges of the paper close together. Do not forget to use staples to make sure that the edges of the paper are together, and it will make it easier to place the paper in the chamber. After that, place the filter paper in the chamber that contains the solvent mixture. And lastly, allow the solvent to rise up until the solvent front. So, based on the experiment that has been conducted, these are the results of the experiment. So now, let's move to how to calculate the RF value of the food dyes.
So, do you guys understand the video now?
Yes.
Okay, so I have sketched this result based on the video that we just watched. So now I will teach you guys how to calculate the RF value. So first, you have to know the distance of the solving front is 7.7 cm. And then you guys have to label the distance of each spot. And then to calculate the RF value, you have to divide the distance of each spot with the distance of solvent front. For example, the first sample is called AMIERA red. So the distance of the spot is 5.4 cm. So to calculate 5.4 divided by 7.7, and we get the RF value, which is 0.70. Now for other spots, you can calculate it the same way that I just showed you. So do you guys understand now?
Yes. Thank you, Aimie, for the explanation.
Thank you for teaching us.
Finally, we can understand how to do the experiment of paper chromatography and how to calculate their value.
The conclusion is the paper chromatography experiment that had been showed successfully separated the components present in different food dyes. Through the process of chromatography, the pigments of each dye show distinct bands of color. And this method has proved the effectiveness of paper chromatography as one of the techniques for separating food dyes.